here and move on to standard kind of wiring layout for it. Again, just kind of start along the top and then we can move down to the bottom. There is a main switch we haven't talked about yet, but terminals 1 and 2. If someone wanted a hardwired switch or maybe a shutdown signal from another device and they wanted to use that to shut down the EKC, maybe a phase loss, for example, there are terminals that can be used for that on 1 and 2. Then you get into more of the main settings or terminals that are related to the controls. The 0 to 10 that we've mentioned for the ICMTS, which that's the valve and ICAD. We'll get into a little bit here too. That's the actuator that goes on top of the ICMTS that actually receives the 0 to 10 from the EKC. That's 2 terminals that you're going to be wiring to just about every time to come out of that controller into that valve.
So Chris, the 1 to 2, for example, if that was left open, if someone didn't have that closed on a closed relay, that wouldn't start up, correct?
That's a good point. Yeah, if you're not using this for the intended purposes here, you actually just want to jump those 2 terminals out. It's kind of just in a run mode all the time.
Yeah,
is one way to describe that. But yes, that's correct. If you're not using this for some sort of a shutdown signal, just a little jumper wire between those 2 terminals so that you're not running into anything. And this would probably be something you'd notice right away on a startup. Yeah, I think I've got everything in place. Why isn't the controller operating? Why aren't my valves starting to modulate?
yeah.
And you would get an error code that's related to this, and you would know that that's exactly what that means, that those 2 terminals have to be jumped out.
And then when we go to 5 and 6, that is the valve. 0 volts is the valve closed, 10 volts is the valve open. So if I go on it with my meter to 5 to 6 and put it on DC volts and it says 5 volts DC, that means it's 50% open. So I should be able to match that up to the ICAD. So I look at the ICAD, if it says 5.0, I should be 5 volts on there, correct?
Yep, and I've got a nice little ICAD handy too here, but yeah, if you can see there's a little glare there, I apologize, but there's a screen right at the top, and that should be showing that opening degree that would match on a 0 to 10 volt scale what voltage you're seeing there. On the lower end of the controller now, again, the 2 pressure transducers we have. So PGC, and we love our acronyms and abbreviations, and these are consistent is one of the good things. So abbreviation you see here on the 326 would be the same with our pack controllers as well. But PGC, our gas cooler pressure transducer, this is at the outlet of the gas cooler for our high pressure valve mainly. And this does have to be a bigger range. So this is a 159 bar or just over 2000 PSI range on this transducer. They look very similar. As you'll see on the receiver transducer, the range doesn't have to be as high, and we typically use a 59 bar transducer there. But you do want to make sure that the right transducer is in place, because it's not too hard to accidentally install a 59 bar transducer where on the high pressure side of the system where it needs to be reading 159 PSI. So we put labels on the transducers with the part number and the pressure range and those types of things to help with that.
Yeah. Always check pressure range. It doesn't matter what pressure transducer it is, because a lot of them look the same from all the different manufacturers, but the pressure range is different, right? So it doesn't matter. You have to check that and make sure it's the right range, because if you put the wrong range one in there, just say you put 159 and 59 bar one, it's going to not know where it's at all. Like it's going to think it's in a different location. So what happens, just say if they do put, let's say 159 bar, the gas cooler one in a receiver one, what would happen to the controller?
In that case, you're reading a larger range than you think you are, and the voltage would actually be lower than what it should be, and so you'd be reading or you'd be reporting a lower pressure back into the EKC because of that. So yeah, you would definitely see some issues with the receiver. You could blow a relief valve because the pressure's higher than what you think it is because of that transducer.
Yeah, exactly. Is there a way to test what that pressure transducer's reading with your meter through 14, 15, 16?
Yeah, so the 2050 here, this is a ratiometric transducer. And so we basically, the way that works is you've got a terminal 14 here where we would send 5 volts out to the transducer, and then you get for the gas cooler 15 and 16 back, and for the receiver pressure we're on 16 and 17. It looks like you should be able to read a voltage back from that transducer in either case, and it's going to be between a range of 0.5 volt and 4.5 volts. And so kind of similar to what we talked about on the 0 to 10 signal to the high pressure valve. here, that voltage is going to fall somewhere between 0.5 volt and 4.5, and you can correlate that to your pressure range, either the -1 to 159 or -1 to 59 bar. And so if you're using a meter, then you can see what that voltage range is there. And then we'll show in a few minutes here where there are some parameters in the EKC as well, where you can also check what pressure reading the EKC thinks you're getting.
Yeah. Okay, perfect. Because I've seen it before where there was a failed transducer, for an example, and the technician was reading off the controller of the system, but not the EKC, because this is standalone. They were thinking it was reading this pressure. It actually was reading the wrong pressure, and that's why the high pressure valve would not open. Is because they had a faulty pressure transducer on the system, but on the main controller, it was saying a different pressure. So you always have to check this controller because it is a standalone controller.
Yeah, definitely. And we do have the display, which is a big help, but you want to compare that and then work down from there. And if it does get to the point that you have to take a meter and just flat out go right to seeing if you've got voltage there or not, and if it's within that proper range, then those are definitely some troubleshooting steps that you want to keep in mind.
Yeah, awesome.
And then we've got terminals. We move on to 18 and 19 here. This is that very important temperature sensor we've got on the outlet of the gas cooler. And again, this sensor defines what pressure target we're going to have on the high pressure side of the system. So very important that we have that obviously wired properly. It's a PT1000, so there's no polarity to worry about, which is good. But just the installation of it on the opposite end, on the pipe at the outlet of the gas cooler itself, I just go back and harp on it again, that very close to the outlet of the gas cooler and insulated are two very important parts of the installation of that sensor.
Does a strap come in with that, or is that a technician need to put that on? And what do you recommend? Because I know I've seen lots of it out there today, and I may have even done it putting zip ties, which is the thing you cannot put on any temperature probe because they'll get brittle over time, they'll break. And I've seen that causing major issues, having that loose on the pipe. Is there anything that you guys recommend to tie it down with?
Yeah, I think we actually, at one point, I don't know if we still do or not, but we actually shipped them with some small zip ties in a bag with the sensor. It has a small spring on the top of it and the curvature to the probe that helps it kind of fully clamp onto the pipe. Yep. But I'd say zip ties are what I agree with you. Especially if you're on the roof, that it's going to be exposed to some elements that zip tie and wear out pretty quickly. But that's probably what we see the most of used to hold it down.
Yeah, so you can use all around or something that'll hold it on, some sort of strapping, kind of like your TX bulbs. Like if you have something there, you don't want it to be dissimilar metal, because you're going to either have stainless steel coming out of that gas cooler, or you're going to have the high pressure copper.
Yep. Mm-hmm.
And these metals are, I think the edges of them are stainless. Is that right?
That's correct.
Yeah. Yep. So you just want to make sure that you strap it down properly and insulate it really, really well.
Yeah, we've had those calls for sure where a guy doesn't understand why the valve's either all over the place or it's not opening or closing when it should be, the high pressure valve. And we get around to asking some questions, and it's usually not the first place we go to because we assume it's been installed properly. But there's definitely been times where we've asked that question and come to find out they didn't insulate it at all. And
I've also seen, Chris, where they bring like an Emerson or a Copeland sensor up to it. So they're using the 10, those 10K things, or a microthermal one, different than the PT1000. And it has to be the specific one that Danfoss sells as well, I believe, because I've seen it where the NTC, they're different than the PTC because they're negative temperature coefficient, but they have different resistance charts. So one reacts faster than the other. So if you don't use the correct one, that you could be getting the wrong resistance into the controller. Is that the same with the PT1000 that you guys sell? Or can you
we always would want to see this one. We know that there aren't issues with it. We've seen not just maybe in this application, but even on the case side where it's the same type of sensor, PT1000, that third-party sensors have been used, and whether it's tolerance or the temperature to resistance ratio isn't the same. We've seen issues with that.
Yeah, so just make sure always, it doesn't matter, always get the one that the manufacturer of that specific controller recommends. It'll save you a lot of grief.
Yep. For sure. 18 and 20 here. This is the heat reclaim signal that I had mentioned a few minutes ago. So this isn't mandatory usage or input. This would be optional if we have heat reclaim and if we want to offset the high pressure target. So 18 and 20 is where we would wire that 0 to 10 signal from, which will be coming from something external, whether it's, again, the full rack controller that's being used or something else. That's the two terminals we would wire to for that signal. And then we get into our receiver.
That is
Yep.
built in on the pack controller, right? Or would you have to send a 0 to 10 volt signal?
Pack controller, we've kind of gone a few steps further with heat reclaim. So we don't,
Okay.
if you just want to offset the heat, the high pressure target for heat reclaim, you typically wouldn't need this signal. But if
Okay.
you want to start to get into some of the more in-depth features we offer, as far as maybe starting to cut back your gas cooler fan speed, or if there's a full bypass piped in to go all the way around the gas cooler, then most of those applications you would need a similar input coming from another part of the system to tell
Fantastic. Yeah.
the pack controller what to do.
Cool. I'm excited to learn about that one.
Receiver bypass valve here. So I've been talking CCM, but we even had a model prior to that in ETS, which was one of our older electronic expansion valves. But regardless, it's a 4-wire stepper valve that you're going to have tied into these terminals 21 through 24. The leads coming off of the valves are color coded. So that's obviously a very important part, because these are typically bipolar motors that we're driving. So the wires have to be in the right order so that we're driving the motor we think we are, and we're driving it in the proper direction. If we're having problems right off the bat after an installation with receiver control, if the pressure's all over the place in the receiver, it could be that valve's just not modulating in the right direction because it wasn't wired properly to the device, whether it's an EKC or a pack controller.
Yeah, so either like 22 and 23 mixed up, so your black and your red are opposite. That potentially it's supposed to be closing, but now it's opening when it says it's supposed to be closing. And will you see that on the screen as well? So the screen's going to say I'm 100% open. Is there a setting where you can look at that valve where it's at in the controller?
Yeah, there is. There's a parameter, that up here.
Because that would be a key. If it says it's really supposed to be 70% open and it says 70 on the controller, but you know it's not 70% open, it could be the wiring of it.
Yep. I'm going to bring another slide or screen in here just real quick. This is from our user guide on the EKC. And so we won't look at all the parameters here now, but one of the things you can see is for someone that's scrolling through the parameters, and this would be using those 2 buttons right there at the controller itself. But any parameter that starts with the letter U, it's classified as service, but it's basically readouts or statuses from the EKC. So a parameter like a U24 here, this would tell us in the EKC what opening degree we think we're telling the valve to be at and that it should be at. And yeah, obviously with stepper valves, calibration can come into play, but in terms of where the controller thinks the valve's at, this U24 parameter would give you that value. So if we're saying 50%, but we're not wired properly on the leads coming off of the CCM back to the EKC, then it's very possible we could be fully closed or fully open when we think we're maybe at a 50% mark.
Perfect.
And then this EKC, last point I'll just touch on, pretty straightforward, but it is a 24-volt AC device. So we get guys that maybe questioned or tried it without asking first, but if they try to throw 24 DC on here, it's a good chance you could kill the controller, or at a minimum not have it run properly. So yeah, it is a secondary 24 AC.
Is there a specific volt amp one that you need? Does it need to be 10 volt amps, 40 volt amps?
Yeah, I'll have to look that number up. I don't have that one on the top of my head here. But yeah, there is a VA rating on there that we'd want to adhere to, just because it is driving stepper valves.
Yeah.
There's maybe a little bit of a higher rating on the controller because of that.
Yeah, because I've seen it before with other electronic valves where people just kept adding on to the transformer, other components, and then it didn't have enough volt amps to open and close the valves accordingly. So just be aware of that.
Yep, I agree.
And one last thing, what is the distance that I can wire these to? Like, so is there a minimum distance for the transducers, the temperature probes that probably can go further, as well as the valves themselves? Because I know in the manual it says 5, I believe it says 5 meter, depending.
Yep. Yeah, on the receiver, flash gas bypass valve, that's where the 5 meter limitation would come into play there. Sometimes we have filters or kind of that can be used to extend distances on some of our stepper valves, but we typically like to see that within 5 meters. And most times I'd say it is, because the controller and the high pressure valve, or I'm sorry, the receiver bypass valve, they're typically both at the rack.
Yeah.
That's usually not an issue. And then when you get into the other items here, the transducers, the 0 to 10, you're worried about maybe some voltage drop. As long as you're within a few hundred feet, we don't see issues, and that's normally more than enough distance to cover what we would see for the wiring between those 2 devices.
Yeah. And one thing I didn't ask you too is the U on the ICAD. What does that do? The wiring out coming up and above the ICAD valve. Is that just an output signal to send to back to a controller to you there?
Here. Yeah, we did have some newer versions of the ICAD where there's a feedback, pair of wires for feedback to tell you what opening degree that we think the valve is at or that it is at. So that's tied to that feedback signal coming out of the ICAD.
Okay, it's a feedback signal. Perfect.